Hello. Running simulations help you to quantify the likely performance of a building. In this tutorial, I'll show you how to set up a simulation in DesignBuilder and review the simulation's options dialog. I'll review those results in the next tutorial. Before setting your calculation options, you can switch off any zones that are not required. For example, you may only want to look at the preliminary results of a few of the key occupied zones during early stage or QA checking simulations. Switching off less important zones, such as the WCs and storerooms, can help to speed up these test simulations. This is done by navigating to the zone and deselecting the Include Zone in Thermal Calculations option on the Activity tab. Alternatively, you could switch off all blocks and zones at building level and only select those required. The zone names are greyed out in deselected zones. It is important to note that when a zone is switched off, its surfaces become adiabatic. That means there is no energy transfer between excluded zones and adjacent zones. Switching off a zone also means it is excluded from the airflow network in calculated natural ventilation simulations, which could block airflow paths. Once you've completed your QA checks and are confident with your model settings, you can start the simulations. To do that, I first select the simulation screen at the bottom to view the simulation data. This calculation update option is shown unless there are up-to-date results already in your model, in which case the results will be shown. The calculation dialog box can be accessed by clicking on the Update Data option. The Calculation Options dialog enables you to specify the key parameters of the simulation. I will give the calculation the name Tutorial Simulation. DesignBuilder also provides a number of typically used simulation periods in the info panel, which can be selected by left-clicking on the relevant option, such as the Summer Design Week. Note how the simulation period from and to dates have changed. The start and end dates for these summer and winter options are automatically derived from the statistics data in the currently selected hourly weather file. If the hourly weather data was loaded from a custom weather file that did not include statistics data, then the data may not be available to allow these links to typical periods to work. In this case, you can select the dates manually. The Annual Simulation option sets the simulation to run for the whole year. The Summer Design Week and the Summer Typical Week relate to the hottest week and a typical week in summer respectively, and All Summer relates to the summer period from April through September in this Northern Hemisphere weather file. The Winter Design Week and the Winter Typical Week relate to the coldest week and a typical winter week respectively, and all winter relates to the period from October through March. The start and end dates can be manually specified. You can also define simulation periods for multiple years. These output intervals for reporting options define how frequently data for your selected outputs is collected during the simulation for display afterwards. It can have a significant impact on simulation and results processing time, so you should generally try to use the least frequent option relevant to your purpose. Here, in the Options tab, you can set the number of times per hour that the calculation engine solves the building thermal network. Increasing the number of time steps generally improves the granularity and precision of calculations, but slows down simulations. A minimum of 4 steps per hour are recommended for Energy Plus simulations using simple HVAC, and a minimum of 6 where detailed HVAC and calculated natural ventilation are selected. You can select the most appropriate control radiant fraction from the temperature control drop-down menu. The different options can give significant differences in results, and using operative temperature control usually leads to a higher peak loads and heating and cooling energy consumption. A useful discussion on the differences between air and operative temperature control is also included in the program help. These solar options are switched off by default to minimize simulation time. They are normally only selected when there are significant adjacent buildings, or where the building geometry could result in significant reflection between parts of the building or when shading of ground reflected solar is important. These solar options may be important for many buildings, so we recommend that you review the full details in the programme help. This model reflections and shading of ground reflected solar can be used to include the effects of shading and reflections from other surfaces on the model building and adjacent buildings. This option also ensures that solar radiation reflected from the ground is shaded by component blocks and other building surfaces. The solar distribution option determines which surfaces provide shading. It should generally be left set to the default full exterior option, which assumes that all beam radiation entering a zone falls on the floor and provides a reasonable balance between simulation time and accuracy. This option takes into account the effect of exterior shadow surfaces and window shading devices. The settings under the advanced header should only be changed by advanced users who understand the implications of changing this data. The Output tab in the Simulation Calculation Options dialog provide options to control the data generated from simulations. You should only select the options required, as excessive data storage can slow down simulations and prevent large simulations from completing in extreme cases. There is some very useful guidance here in the programme help on working with large models and appropriate ways to minimise simulation time. Selecting the building and block output of zone data option causes average and total zone data, such as average temperatures, internal gains, fabric transmission losses, etc., to be generating for building and blocks. This option doesn't affect the generation of energy consumption and CO2 emissions data at building level. Where appropriate, you can switch this and the Allow Custom Outputs options to minimise data processing and simulation time. We would advise that you read about these options in the programme help before doing that. By default, data for unoccupied zones is excluded from block and building totals and averages. Check this option to include data for unoccupied zones. You can choose which outputs you want to produce graphical results for under the Graphable Outputs options header. Selecting this surface heat transfer option results in large amounts of data being generated, as Energy Plus must generate output data for every surface and window in the zone. Only select this if you need to look at the zone heat balance. Detailed options such as internal gains, which enable you to check how the building performs at various times of day and year, will of course be required to validate your model prior to running the annual simulation. A model checking strategy is discussed in the earlier tutorial on Model Grid Data View Tool and QA checking. You can restrict the simulation comfort and environmental output using these options. Choosing just occupied periods means that comfort and environmental data is only output during times when the zone is occupied, so the results become more meaningful for summer overheating analysis, etc. This user-defined schedule option can be used to restrict the output based on the reporting schedule. The environmental option generates temperatures and humidity data. This fresh air supply option includes total infiltration, natural ventilation, and mechanical fresh air supplies. These can be viewed separately in the results viewer, which will be discussed in a later tutorial. The adaptive and SIBSI TM52 and TM59 options are often used for compliance purposes. Selecting this temperature distribution option enables you to view a graph showing how many hours per year each zone is at, above, and below each temperature band. If this is the main purpose of your analysis, for example, to produce a summer overheating report showing hours over 28 degrees Celsius, you can deselect most of the other options and request only temperature distribution and monthly and annual data. This will enable you to produce these results more quickly. The other options are fairly self-explanatory and may be selected when required. Standard Energy Plus annual and monthly summary reports can be produced to provide a wide range of summary outputs for the overall building and its constituent components. Some of these are very useful, so it would be worth you taking a look to see what outputs can be generated. There are lots of other reporting and output options available in DesignBuilder, either directly from input fields in the interface or via scripting or inserting code into your model's IDF. These are beyond the scope of these introductory tutorials, but you can find out more in other resources such as the program help and webinars. The Simulation Manager allows you to run and control multiple parallel simulations and access the results. It allows you to run simulations whilst continuing to work on your local machine or to use network servers or the cloud to run your simulations. How to use Simulation Manager is covered in a later tutorial. Now that I have reviewed all the key calculation options input data, I can run the simulation by clicking OK. This will be covered in the next tutorials. This finishes our quick review of setting up simulations in DesignBuilder. If you want to learn more about the topics introduced in this tutorial, including top tips that will improve your modelling efficiency, then our QA, simulation and comparing results on-demand training session explores this in more detail. We hope you found this tutorial useful. Further information on the specific topics and wider application areas can be found in the comprehensive DesignBuilder program help, other tutorials and webinars, and our on-demand training.